This is the 2022 AMC 10A problem number 21. A bowl is formed by attaching 4 regular hexagons of side length 1 to a square of side 1. The edges of adjacent hexagons coincide, as shown in the figure. What is the area of the octagon obtained by joining the top 8 vertices of the 4 hexagons situated on the rim of the bowl? Okay, so this can be a confusing problem because it might be hard to know where to start. But the important thing to keep in mind is the fact that these will all be like the same side length x, right? However, there's a clever way to figure out what these side lengths will be. And once we do that, finding the area will be very simple. We can draw this line down here. And if you'll notice, this creates a symmetry because we know this is root 2 because it's a square, right? 1, 1, root 2. But if you notice, because the hexagons are connected with this side here, clearly these 2 points are the same distance apart as these 2 sides, right? Like if we were to draw the hexagons, if we were to draw them head on, the angle would look like this. It would look like this. There would be perfect symmetry. So this distance here would be the same as this distance. And we know the distance down here is the square root of 2. So therefore, this distance up here is also the square root of 2. And from here, we simply have an octagon that we know to be we know it to be symmetric on all sides. In other words, we know it to be equiangular. And if we draw this sort of grid on top of it, we know that by symmetry, because it's 4-way symmetric, right? Of course, we would form right angles. There would just be a square in the middle. And therefore, we know this is 1, 1, right? All the way around, because we need to have 1, 1, root 2, right? That's how the right triangle is. And clearly, the area of these 5 squares is all 1. And the area of these sections here is 1/2, 1/2, 1/2, 1/2. And our answer is just 5 plus 4 over 2, which is 7.